So welcome back. This is sequence 4. We start to learn about the real Ocaml system. Let me give you a short overview of the system itself. So Ocaml is a mature system today. You have a rich set of development tools. For example, there is a modern package manager for installing the libraries you need and speed up your development. This is called Ocaml. You can find it here, downloaded from ocaml.ocaml.org. With this package manager comes a repository that has hundreds of package libraries for you. But you also have a debugger, you have a profiler, there are memory profiler, many other tools like this one. Let me focus now on the compilers that comes with the Ocaml system. There is one very useful piece of the system which is a REPL, the ReadEvaluatePrint Loop, which is used for fast development and that you will use in this particular course. Then you have the Ocaml C bytecode compiler that produces code compiled into a bytecode which is portable. So basically you can port it across all architecture. You can see more details on portability here. And then you have the Ocaml opt series of native compilers that can target different architectures, typically 386 architectures, 64 or 32 bits, PowerPC, different variants or flavors of ARM, and then you get very fast executable, much faster than the bytecode compiler. Of course, you lose portability in that case. And then finally, the last member of the family, GS of Ocaml, that's a revolutionary compiler that compiles Ocaml code into JavaScript directly, and that's fundamental for building web applications. But let's focus for a bit on what this really means. What is a REPL? What is a ReadEvaluatePrint Loop? Well, in Ocaml, we have this ReadEvaluatePrint Loop, which is generally called the top level by Ocaml programmers. What it really does is to read your program phrase by phrase. When you type them, then you hit return. It is read by this system. As soon as a phrase is complete, this phrase is compiled, not interpreted, really compiled on the fly, and any error found is reported. Typically, type errors are reported right away. Then the compiled code is evaluated, and the result obtained and printed for us, just in front of us. Yeah, this is incredibly useful when trying out ideas, new ideas, try to develop some sophisticated part of an algorithm, because we can see the result produced by the program right in front of our eyes in this top level, without having to write a parser, a printer, all these kind of things which are kind of cumbersome. So let's see a typical interaction that what using this top level really looks like. Well, if you have Ocaml installed on your machine, but it is not needed for this course, you run Ocaml. Then you get a banner like this one that tells you this is Ocaml version 402.0. Then you have this prompt, here, this number sign here, just a prompt, it's just telling you, I'm listening, just please type in some piece of a program. Then you can type a program in, or a phrase, like this one. Well, you don't know the language yet, but let me just go through what this means. So we are calling the map function in the list module. We are passing to this map function another function, which is a nameless function. It just waits for an x and gives you back an x plus 1, so it's a successor function. And then takes a list. Yes, this is syntax for representing a list that has 6 elements, from 1 to 6. As soon as you hit enter here, what happens? This phrase is passed to the compiler, it is compiled, evaluated, types are checked, you get the result, and the result is printed for you. And actually what you get, this blue line here, is the system coming back to you by saying, well, you have written a piece of code that does not define any new identifier. The type of the result is a list of integers, and the value of the result here on the other side of the equal sign is this list here, which is unsurprisingly the number from 2 to 7, since I have added 1 to all the numbers from 1 to 6. Okay? So the big advantage is that the result is now right in front of our eyes. I didn't need to write a parser to read this particular data structure here, or a printer to print the data structure out. For this course, you will run the Ocaml top level right in your browser. There is no need to install anything. You just go to the page of the exercises, and it will just open up for you. You will have the same interface for everybody, no differences or hassles. It is fully integrated in the learning system, so the result of what you type will be saved from the session to the other. And there is no need to depend on external server. There are many other places where you get the impression you're typing a program in your browser, but what really happens is there is a big server somewhere where your phrase is sent and the result is fetched. This is not the case here. Looks like magic. Well, it's almost here. It almost is magic. Because actually this top level environment is entirely written in Ocaml. Well, it has been compiled into bytecode using the Ocaml C bytecode compiler. Then the result is compiled into JavaScript using a JS of Ocaml compiler and some other bindings, of course. And then all this is loaded into your browser, just a JavaScript code, as soon as you access the web page. Okay. So maybe this is time to try this out. Let's see a couple of examples. Well, okay, so here we see a typical example of the exercises you will have to do during the course. You will have some text here telling you what kind of activity you are expected to perform. In this simple example, we are just asked to complete the definition of the plus, minus, mult, and div operation on the integers. This area here is a text editor where in general you will find a template of a program. In some programs you will need just to complete these templates. In some other cases you will need to write them from scratch. In this editor you can actually really edit our program directly. Let's do it. Okay, so we have to complete the definition of the plus function that takes two arguments, x and y. So probably, even if we don't know the language yet, it will be something like x plus y that I need to put here. Then we need to complete our phrase with a double semicolon. Fantastic. I'll try to do the same for the other example. So minus x minus y times, well, see, here there is a catch. The definition which is here, it is not exactly the one which is correct. So sometimes you will need to change even the template that you are given. So x times y, and then finally divide x divided by y. Okay, that's very simple and straightforward, just to show you the example. Once you have done this, you may decide, for example, to evaluate your program. You can click on this evaluate button here, and everything you have typed will be sent to the top level, which is just running in front of you. So you see the function plus, minus, times, and divide has been defined. We find the type as produced by the system. We can get back to the text editor, so you can switch between the interactive section and the text editor as much as we want, or you can just go to the interactive section without evaluating anything. Okay. And even before evaluating a piece of code, we can just click on this type check button here. You see the green flash there just showed us that everything is fine. This performs type checking and syntax checking on our program. Let's add a syntax error just for you to see what happens. So I am removing one of the argument of the plus here. I will run type check again. You see, now there is a syntax error, and it is actually annotated in the editor for you. You see, I'm just hovering here. Well, at any time you can of course reset the template. When you do this, you will, if you click here, you can back to the original initial template, but in this case all your work is lost, huh? So just be careful before clicking here. And if you want, if the space is not enough for what you're trying to do here, then just click on the full screen button. You will get a full screen presentation where you have the editor on the left, the top level on the right, and of course if your screen is big, as in my case, you can with Ctrl+, you can increase the dimension of the windows or reduce it with Ctrl- until you feel comfortable. And once you are here, for example, we can decide again to complete the definition of plus, x plus y, which is here. I can select this section with the mouse and decide to evaluate only the selection, for example. You see, now we have defined only this plus. I can type directly in the interactive session, +3, 4, and that's it. And you can, of course, come back to the original version. Now, once you have done all your programming, you are happy with the result, you should push on the button check to have your exercises actually tested for you. Let's do it. So for example, we can make a mistake in minus, say I put the minus in the other way around, 4 times, we can put x, y. Let's make only just one mistake in this exercise. Okay, so I suppose that I have tested this, I type checks properly, I have evaluated it, tested in my environment, I'm coming back, I'm ready to get my note, my grade, and so I push on the check button now. This check button will actually interact with the fun platform you are using to follow this course, and the result of the check are shown to you in this nice summary. So in this case, for example, we didn't pass all the checks, and so the exercise is incomplete, but you can see function by function that we have been asked to produce, which one are right and passed all the tests, like plus here, which is the right definition, and which one were faulty, like in minus definition, where we actually didn't get the good results. Okay? So of course you can come back, correct the function which is faulty, then submit again, and we do hope now that everything is fine. You see, so the exercise now is complete, we get all the 12 points out of 12, and this will be actually stored in the fun platform, that so you can follow the evolution of your learning.